Hello there, I'm Mohammed Bello Garba from Community Medicine Department, ABU Zaria and ABU Teaching Hospital. This is COMM 201 Biostatistics. In the first module, we gave a general introduction of the science of biostatistics, definition of terms, and its branches. We mentioned it has two major branches, descriptive and inferential statistics. In this module, we'll take some demonstration about measures of location as part of the descriptive statistics. Now, we have largely three measures of central tendency, we call them mean, median, and mode for the descriptive statistics. We also have measures of dispersion, which includes standard deviation, variance, and range. We can also go ahead and talk about interquartile range, but we'll just pick one from each. So we demonstrate. The presentation of data is also often described in terms of descriptive statistics, whereby you present or summarize your data using numbers and tables and then graphs. Using numbers, you can use mean, proportions, and percentages. You can also use these measures of central tendency, mean, median, and mode. You can use measures of dispersion as well, range, interquartile range, variance, and standard deviation in presenting and summarizing data. You can as well use tables, simple tables, 2x2 tables, contingency tables, and complex tables. You can also use graphs depending on the nature of the variables. You can either use histogram, or you use pie chart or bar chart, or frequency polygon, as the case may be. But now quickly, let us look at descriptive statistics, summarizing and presenting data using numbers, and looking at measures of location. Let's take as an example. If we have 15 students that sat for a CA test and we have their scores, let's see how we can calculate both the mean, median, and mode as a representative of the examples. If, for instance, we take the scores of these students to be 58, for instance, if the scores are like this, 58, 34, 57, 54, 54, 44, 57, 61, 21, 36, 57 again, and 44, 47, 38, 48, 51. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. These are the scores of the 15 students. And we want to calculate the mean. So we should first know that mean is given by an expression, summation of x all over n, where this x is the individual observations, individual marks, 1, 2, 3, 4, up to 15. And the summation means the total of the sum of the individual observations. And n is the total number of the observations. So if we take these sums, we sum it up for all these 15, for the 15 students, we will get a total of 708. And then our total number of observations is 15 students, 15 marks. If you do the arithmetic, it will give you 47.2, which is the average or the mean of the scores. Mean score of these 15 students is 47.2. Mean is very important in statistical inference. One, even in the descriptive statistics, it gives you the general idea about the average performance of the students in the class. However, it can be affected by skewed values. Very large values or very small values will affect the mean. That is why it is usually good estimate for measures of location when the distribution is fairly normal. Now, we also need to know that we'll come to explain most of the statistical inference test statistics and hypothesis tests use mean as their major means of denominator, either as standard deviation or standard error. Now, if we want to go to the second mean of central tendency, you have to arrange these values in either ascending or descending order and then take the median value as the middle value. So if we take it in ascending order, you get 57, 57, 57, 54, 51, 48, 47, 45, 44, 38, 36, 34, and 21. So if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So there are 15 of them arranged in either descending or ascending order. Then you take the middle one. So if you count 15, then you count 7. 7 right, 7 left. You get 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 6, there is 1 remaining here. 61, 58. We miss 58 here. So 1, 2, 3, 4, 5, 6, 7. 48 will be our median value. 7 to the right, 7 to the left. So one of the importance of median is that it is not affected by extreme values. And it is very good when you have a data that is not robust in its normality. And some statistical tests also use median as measure of inferential statistics. The next mode of exposure, mode of measure of location is mode, which presents the most frequently observed value. And here, if you look at it, 3 students have a score of 57. So 57 is our mode, the most frequently. It is the one among these measures of location. It is the least used for statistical inference, but it will give you an idea about how frequent an observation comes. And usually we have unimodal or bimodal presentation of data. So if you only like this one, only have one mode, and you can have, if you have other observation that occur more frequently, you can have that. Then quickly we'll go to measures of dispersion. And we said measures of dispersion are largely range, standard deviation, and variance. Range is the simplest of them. It is the difference between the largest observation minus the smallest. So for instance, in this, the largest one is 61 minus 21, which will give us 40. So our range for this description of the marks of the student is 50. But then if we want to see the variability, then we compute the standard deviation of this. And standard deviation is given by an expression which shows standard deviation is equals to the root of difference between x minus x bar squared all over n minus 1. We already know our mean, so we just describe in brief how you calculate it. So we have our x minus x bar as a table, then we have x minus x bar square. We already know that our x bar is equals to 47.2. So we have all our x starting from 61, for instance, down. So our mean is 47.2. So we'll take this one as the x, all the values, all the scores as our x. Then we'll come to this column, we'll say this x, which is 61 minus our mean, 47.2. Then we get the difference, which is 12.8. Here will be this one, so it will be 12.8. Then we get the square of this. So this is how we continue up to the last one. Then we come here and get the summation of this x minus x bar. We get the total summation. The way we get this summation, we input it into this formula. Standard deviation is equals to summation of x minus x bar all squared 1 minus 1. And then we get our standard deviation. And when we have the square of standard deviation, we get our variance. And with these variables, you can be able to describe our set of data like this scores of students by describing the measures of location like mean, median, and mode, and then the range of the scores and the standard deviation that we can equally use to describe this data. Thank you.